Let us start the series solution of higher order ordinary differential equation. So what we have seen in the last lecture is, suppose I have given the differential equation d2y by dx square plus p of x into dy by dx plus q of x into y equal to 0. Right. We fix any number x0. Right. Then first we are dividing the solution of this differential equation into two parts. The first part is part 1, which adds the singularity of x0. Singularity of x0. What does it mean? Singularity of x0 means whether x0 is an ordinary point or x0 is the singular point. Suppose x0 is ordinary point, then what is the solution? Suppose x0 is singular point, then again we have two different cases. Whether x0 is regular singular point or x0 is irregular singular point. Right. If x0 is irregular singular point, then we don't discuss that what is the solution of the given differential equation. Right. So we are discussing the solution of this differential equation at point x0 only if either it is ordinary point or regular point or that is regular singular point. Right. So first let me discuss what is the format of the solution if x0 is the ordinary point or regular singular point. So in part 2, so this is say part A of the solution where we check the singularity. In part B, if x0 is an ordinary point, right, then what is the solution? The solution yx is equal to summation n is equal to 0 to infinity an into x raised to n. This is the solution. If x0 is regular singular point, I am writing in short regular singular point, then what is the solution? Yx is equal to, I am writing the same thing, summation n is equal to 0 to infinity an into x raised to n. Right. Additionally, here I am writing x raised to n. Again I repeat, we have given the differential equation. Right. We fix one point x0 and the solution is always at this point x0. Okay, yes, I need to make the change. The point is x0, right? So I have to write here x minus x0. This is x minus x0 raised to n because we are fixing the point x0. So we fix the point x0. First we find what is the singularity at x0, whether it is ordinary point, then this is the solution format. If it is not an ordinary point, that means it is singular point, then again I shall check whether it is regular singular or irregular singular. Suppose it is regular singular, right? Then this will be the format of the solution x raised to m into summation n equal to 0 to infinity a n into x minus x 0 raised to n. Now, this is the format of the solution. How do we solve the exercise that we are discussing with this particular exercise? So first I am discussing when x0 is an ordinary point, right? Then we shall discuss when x0 is the regular singular point. What is the exercise here? Find the series solution of d2y by dx square minus x dy by dx plus 2y equal to 0 at, now I am fixing the point, at x0 is equal to 0. Right. So as we discussed, we are dividing the solution into two parts. In part 1, we shall check the type of singularity of x0, and corresponding to that type, we fix the solution format, and then we shall discuss part B. So in the part 1, what I have given? I have given this differential equation. d2y by dx square is y double dash, I am writing in this way, minus x into dy by dx is y dash plus 2 into y equal to 0. This is equation number 1. Right. We have also given x0 is equal to 0. Right. This is we have given in the exercise. Now let us compare equation 1 with y double dash plus, you know this format, q of x into y dash plus q of x into y equal to 0. Right. Keep in mind, whenever you are comparing, the coefficient of y double dash to the given equation must be 1. Right. Here also the coefficient is 1. Therefore, what is px? Px is equal to minus x. This is my px. And this is my qx. 2 into y is qx into y. And qx is equal to 2. For the singularity, what I need to check? Now, limit x tends to x0 px is equal to limit, what is my x0? x0 is fixed 0. So this is limit x tends to 0. What is my px? px is minus x. And so this is equal to 0. This limit exists. Right. Now let us check what happened at x0 for qx. X tends to x0. qx is equal to limit x tends to x0 is 0. And what is my qx? qx is equal to 2. Right. So this is equal to 2. And therefore this is 2. So here both the limit exist. Limit x tends to x0 px and qx both exist. Right. Therefore, what we can say? A point x0 equal to 0 is an ordinary point. Is an ordinary point. The nature of the point is fixed. Right, x0 equal to 0 is an ordinary point. So now we are moving for part B. Okay, so part B, what we have given? We have given this equation 1, y double dash minus xy dash plus 2y equal to 0. So now let me write, assume that y of x is equal to summation n is equal to 0 to infinity a n into x raised to n is the solution of equation 1, is the solution of equation 1. right? See, what I have written here, summation n equal to 0 to infinity an into x raised to n. Actually, when I started the session, what I told you, the solution is summation n equal to 0 to infinity an into x minus x0 raised to n. What is the value of x0 we have given? X0 equal to 0. Right. So when I substitute x0 equal to 0, this is summation n equal to 0 to infinity an into x minus 0. Right. Which becomes x. An into x raised to n. So this quantity I have mentioned here directly, that this is the format of the solution. Now let us see what is this quantity actually. Okay, now for this particular exercise I am writing here which is the solution, and the explanation mostly I write here or I use the different color, right? What we have given, the solution yx is this, is equal to summation n equal to 0 to infinity n into x raised to n, right? Now what is this actually? This is equal to, now see, when I substitute n equal to 0, then this an is what? This is a0 into x raised to 0. X raised to 0 is 1. So actually this is the constant coefficient a0. When n is equal to 1, because n starts from 0, goes to infinity. Right. So n equal to 0, 1, 2, 3, 4 up to infinity. So when n is equal to 1, this will be a1 into x raised to 1 plus when n is equal to 2, this is a2 x square plus a3 x cube plus a4 x raised to 4 and so on. Now see, actually this is the series which is the solution of the differential equation. Now let me explain something here. See how many constants are there? A0, A1, A2, A3, A4, A4, A5, A6, A7 up to infinity. So actually these are infinitely many constants in our assumption. Now see, my actual differential equation is this. See, y double dash plus q of x y dash plus q of x into y equal to 0. What is the order of this differential equation? Order is 2. Order is 2 means what? When do we solve this differential equation? It has only two arbitrary constants, right? Whether, see, again I repeat, this is the second order differential equation. So in the solution of the second order differential equation, it has only two arbitrary constants, right? Here the given differential equation is of second order, right? And in the solution I am assuming that these are the constants, right? Infinitely many constants, but we should have exactly two arbitrary constants. What does it mean? Now in the latter process, right, the process which we are going to discuss here, in which we will show that this a2 is the combination of a0 and a1, this a3 is also the combination of a0 and a1. I mean all these a2, a3, a4, these are nothing but the combinations of a0 and a1, right? And which kind of combination it is, that also we shall prove here, right? We shall show which kind of combination. So now let us start. What we are saying, this is the solution yx, right? That means this is the solution of equation 1. That means the solution satisfies this differential equation. Now in this differential equation yx, that already we have, what is y dash and y double dash, that we need to find out, and then we substitute to this differential equation, right? So what is y dash here? Therefore y dash x is equal to, okay, so this is the derivative, summation an as it is. What is the derivative of x raised to n? Is n into x raised to n minus 1. Right. Now, what about the suffix? Here it is 0 to infinity. Should I write 0 to infinity? I am writing here n is equal to 1 to infinity. Can you tell me why I have written 1 here? See, this series is a0 plus a1x plus a2x square plus a3x cube. I am differentiating, right? So what is the derivative of a0? Is 0. What is the derivative of a1x? So a1 is the constant. Derivative of x is 1. What is the derivative of a2x square? So it is 2 times a2x, right? What is the derivative of a3x cube? So a3 as it is. Derivative of x cube is 3 times x square and so on, right? So the derivative of this is actually a1 plus 2a2x plus 3a3x square and so on. So here the suffix is starting from 1, 1, 2, 3 and so on. So n is equal to 1, 2, 3 up to infinity, right? This is 1 into a1, 2 into a2x plus 3 into a3x square, and that is written here and an into x raised to n minus 1. Clear? I need the second order derivative also. So therefore y double dash x is equal to, again I differentiate y dash. So n I already have, an I have, so this is an. What is the derivative of x raised to n minus 1? Is n minus 1 into x raised to n minus 2. So this is n minus 1 into x raised to n minus 2, right? Now here, let us differentiate this again. So what is 0? Has already gone. What is the derivative of a1? Is 0, right? What is the derivative of 2a2 into x? It is 2 times a2 plus. What is the derivative of 3a3x square? Is 3 into 2 a3 into x and so on, right? So if you observe this, then the suffix is are starting from a2, a2, a3, a4, a5, a6 and so on, right? So I am writing here suffix starting from 2, n is equal to 2 to infinity. You need to be careful about this. Y double dash is summation n equal to 2 to infinity and n minus 1 and x raised to n minus 2. Y dash x is n equal to 1 to infinity and a n x raised to n minus 1, and this is our assumption, right? Now we are assuming that this yx is a solution of equation 1, right? We have y dash, y double dash. So now we substitute all these three quantities to equation 1. Clear? What is equation 1? So let us write now. Our equation 1 is this: y double dash minus xy dash plus 2y equal to 0. So y double dash minus xy dash plus 2y equal to 0. Now let us substitute all these values. Therefore, what is y double dash? Summation n is equal to 2 to infinity n minus 1 a n into x raised to n minus 2, right? Minus x into what is y dash? Y dash is this one, summation n is equal to 1 to infinity n a n x raised to n minus 1 plus 2y equal to 0. So plus 2 summation n equal to 0 to infinity. What is yx? A n x raised to n equal to 0. Right, so from the given differential equation, we have this large equation. What is our task? Keep in mind our task is we need to find out what is the relation of A2, A3, A4 with A0 and A1. Right, now see, which are A0, A1, A2, A3, A4, A5, A6, all these are coefficients. A0 is the constant coefficient, that is the coefficient of x raised to 0. A1 is the coefficient of x, A2 is coefficient of x square, A3 is coefficient of x cube, and in this relation also, right, these are the coefficients of x raised to I. So now from this relation, we compare the coefficients, constant coefficient, coefficient of x square, coefficient of x cube, right? And then we find out the relation. So how do we compare the coefficients and how do we proceed? That I am discussing. So now actually our main relation is this, n is equal to 2 to infinity. Now let me explain this. What is this? So when n is equal to 2, what happened? N equal to 2 means x raised to 2 minus 2. So this term contains something. So see, this is what? The first term is this, 2, n equal to 2, right? So 2 minus 1 is 1, n equal to 2, so this is a2 into x raised to 0 plus when n is equal to 3, so then this is 3, 3 minus 1 is 2, a3 into x raised to 3 minus 2 is x raised to 1. Clear? I am talking about only this summation. Plus when n is equal to 4, 4 into 3 a4 x square plus 5 into 4 a5 x cube and so on. Plus we have something, infinitely many terms we have. So this particular quantity has these many infinite terms, right? Minus, this is what? X summation n equal to 1 to infinity n into x raised to n minus 1, right? So when you take this x inside, right? So x raised to n minus 1 into x is actually x raised to n, right? So when you multiply, I shall write everything in detail, right? So when you multiply this x to this x raised to n minus 1, then it becomes x raised to n. Clear? And so now what happened? Here n is starting from 1. So when n is equal to 1, so 1 into a1 into x raised to 1, say. So this is 1, a1, x raised to 1. There is no term of x raised to 0, right? This is with minus sign. Okay, we will fix everything. Minus when n is equal to 2, so this is 2 a2 x square. When n is equal to 3, so this is minus a3 x cube. When n is equal to 4, n is equal to 5 and all other terms. So these are the terms for this particular middle term. This is what? When n is equal to 0, so this is 2 times a0 x raised to 0. When n is equal to 1, so this is 2 times a1 x raised to 1, 2 times a2 x square and so on. Right. Equal to 0. 0 is what? 0 into x raised to 0 plus 0 into x raised to 1 plus 0 into x raised to 2 plus 0 into x raised to 3 and so on. Right. So actually this is the meaning of this equation. Now what we do, we compare the coefficients of x raised to 0, x raised to 1, x raised to 2, x raised to 3 and so on. And here you need to be careful. See, because when I am interested in the coefficient of x raised to 0, see, so the coefficient of x raised to 0, right? So in x raised to 0, which are the terms? 2 into 1 a2, 2 into 1 a2, right? Plus, see, there is no term which is the coefficient of x raised to 0. I mean, there is no constant term, right, here. Now, x raised to 0. So, plus 2 times a0 is equal to, what is the constant term here? 0. So, equal to 0. And this is nothing but 2a2 plus 2a0 equal to 0. So, I can cancel out 2 and 2, and therefore, a2 is equal to minus a0. Clear to you? So, see, a2 in terms of a0, right? We need in terms of a1 and a0, so you can say this is nothing but minus a0 plus 0 into a1. Nothing is wrong, right? Let us compare the coefficient of x raised to 1 here, right? Coefficient of x raised to 1. So, coefficient of x raised to 1. X raised to 1 is here, x raised to 1 is here, x raised to 1 is here also, right? So, all these three terms contains x. So, here it is 3 into 2a3. So, let me write it is 6a3. I am writing direct, right? 3 into 2a3 is 6a3. This is minus a1. Here the coefficient is 2a1. So plus 2a1, and this side the coefficient of x. See, right hand side all the coefficients are 0. So don't worry about it. Right. Okay. So what is this? 6a3 minus a1 plus 2a2 is what? Plus a1. So plus a1 equal to 0. And so a3 is equal to minus a1 upon 6. So by comparing the coefficient of x raised to 0, the coefficient of x raised to 1, likewise we compare the coefficient of x square, x cube, x raised to 4, right? And x raised to 5, x raised to 6, you have to compare infinitely many coefficients, right? X raised to 6, x raised to 7, x raised to 8, because this is the series, right? So how many coefficients you have to mention? You have to mention actually all the coefficients, right? So here now I am explaining. So this is the explanation which is clear to everyone, right? Now how do we mention all the coefficients of x raised to I that we are discussing, right? Okay, so what we have given this, and that is what we represent in the examination also. So therefore summation n is equal to 2 to infinity n minus 1 a n into x raised to n minus 2 minus, let me write, what is that? This x goes inside, so n a n x raised to n, so it will be minus summation n equal to 1 to infinity n a n x raised to n plus, let us see, yes, 2 times summation n equal to 0 to infinity plus 2 times summation n equal to 0 to infinity a n x raised to n equal to 0. So now compare the coefficient of x raised to 0. So for x raised to 0, how do we get x raised to 0? When n is equal to 2, which is possible. Yes, this is possible. See, when n is equal to 2, we have 2 minus 2 is 0. So the term gives us the coefficient of x raised to 0, right? When n is equal to 2. So n is equal to 2, 2 minus 1, a2. 2, 2 minus 1, a2. Right. This term. What I want, x raised to 0. So for x raised to 0, the value of n should be 0. The minimum value of n is 1. So this term does not contain x raised to 0. That is the constant coefficient, right? So this term will not help us, right? So just remove this term. Now the next. What is it? N equal to 0 to infinity. I need x raised to 0. So for x raised to 0, I want n equal to 0. Right, so when we substitute n equal to 0, we have, so plus 2 times a0 is equal to 0. And therefore, a2 is equal to minus a0. Clear? So this is the first relation we have. Now, compare the coefficient of x raised to 1. How do we compare the coefficient of x raised to 1? I need x raised to 1 here. So for which values of n this will be x raised to 1? N minus 2 equal to 1, that is n equal to 3. Right, so this is 3, 3 minus 1. So this is 3, 3 minus 1 into a3. Right, because n is equal to 3 here. See, the value of n will be different for each term. So here n is equal to 3, whether here n is equal to 1, and here it will be n equal to 1. I need x raised to 1. So for x raised to 1, n is equal to 1. That is possible, right? So 1 into a1 with minus sign. Minus 1 into a1 is a1. Again, I need x raised to 1. So a1, n equal to 1, possible. So plus 2 times a1 equal to 0. And therefore, this is 6a3 minus a1 plus 2a1 is plus a1 equal to 0, and therefore a3 is equal to minus a1 upon 6. Right. Let me say this is relation number 2, this is relation number 3. So this is the comparison of the coefficient of x raised to 0, x raised to 1. Now likewise, x raised to 2, x raised to 3, x raised to 4, you have to compare all these coefficients. Right. Now how do we, in general, we are comparing the coefficient of x raised to r. So in general, let us compare the coefficient of x raised to r. Right, x raised to r. So here this will be helpful for x square, x cube, x raised to 4, x raised to 5, and so on. And if possible, whether it will be valid for x raised to 1 or x raised to 0, that also we shall discuss. Now see, for x raised to r, how do you proceed? Go with term by term. So the first term, let me explain here. The first term is this. I need x raised to r. So I have x raised to n minus 2. I want x raised to r. Right? So n minus 2 should be equal to r. And therefore what is n? N is equal to r plus 2. So in place of n, I substitute r plus 2 everywhere. So this is r plus 2 minus 1. Right? So I am writing here, this is r plus 2, r plus 2 minus 1. I am writing everything. Into a n is what? N is r plus 2, so a r plus 2. This is the coefficient of x raised to r from the first term. Right. Now the second term, I need x raised to r. Right. So for the second term, I have x raised to n. I need x raised to r, and so n should be equal to r. This is very easy here, right? Because the direct comparison n is equal to r. So in place of n I am writing r, so this is r into ar. Likewise, here also I need the coefficient of x raised to r. So x raised to r n is equal to r 2 times ar. So now I am writing direct for the second term as well as for the third term minus rar plus 2 times ar. Minus rar plus 2 times ar is equal to 0, right? Therefore, r plus 2 minus 1 is r plus 1, ar plus 2 is equal to, okay, let me write this one, plus, what is this? Minus r plus 2, minus r plus 2 ar equal to 0, right? And therefore, ar plus 2 is what? See, keep in mind, ar plus 2, r plus 2 is suffix. Don't write it as ar plus 2, right? Ar plus 2, so r plus 2 is suffix. This is not equal to ar plus 2, keep in mind. These two things are different. Don't make mistake here, right? So ar plus 2 equal to what? This quantity will go to the right side. So minus of minus r plus 2ar divided by r plus 1 into r plus 2. Right. I am modifying this relation. Therefore, ar plus 2 is equal to minus of, once I take this minus sign inside, then this will be r minus 2, right? So this will be r minus 2 divided by r plus 1, r plus 2 into ar. Clear? Now, this is in general, compare the coefficients of x raised to r. For which values of r this is true, right? In the assumption, what was our assumption? Yx is equal to a0 plus a1x plus a2x square and so on. This is the solution, right? So look at the suffix. Suffixes are 0, 1, 2, 3 up to infinity, right? And here I have given ar. That means the minimum value r would be 0. That is helpful, right? The minimum value of r is 0. So the relation is true for r. Minimum value of r is 0, right? So r greater than or equal to 0. R greater than or equal to 0. Everywhere I write r greater than or equal to 0. But that I always fix after finding this relation, right? I always mention the values. Now see, r greater than or equal to 0 means what? R starts from 0, then 1, 2, 3, 4. That means this is valid for the coefficient of x raised to 0, x raised to 1, x raised to 2, x raised to 3, 4, and all, right? Now, suppose r is equal to 0. Let us cross verify whether this is true or not. Let me substitute r equal to 0 here. So when r is equal to 0, right, this is what? A0, r is equal to 0. 0 minus 2 is minus 2 divided by 0 plus 1 into 0 plus 2 into A0. Right, sorry, this is A2. A0 plus 2 is A2 equal to this, right? So A2 is equal to minus A0. Do we have this relation? Because we have already compared the coefficient of x raised to 0. See, compare the coefficient of x raised to 0. A2 is equal to minus A0. So a2 equal to minus a0 we are getting, right? The relation is correct. This is, say, equation number 3, and that's all. Actually, this is the end of exercise, right? See, we compare the coefficient of x raised to 0, x raised to 1, then in general we find out the relation for the coefficient of x raised to r, and which is valid for all r greater than or equal to 0. Sometimes these r will be different, may not work for 0, right? In other examples we shall see those kind of relations also, and there is particular name of this relation. This relation is called recursion relation, right? Recursion relation. How do you end this exercise? And therefore the solution of equation 1 is yx is equal to summation n is equal to 0 to infinity an into x raised to n, where ar plus 2 is equal to r minus 2 upon r plus 1, r plus 2 into ar, where r greater than or equal to 0. This is the solution. Clear? So again I repeat what we do in the solution. First we have given x0, right? We fix the nature of x0, whether it is regular singular, whether it is ordinary or regular singular. If it is ordinary, then how do we proceed? That method we shall discuss here, right? If it is regular singular, then we shall discuss, right? But again, we shall discuss 3 or 4 more examples of this kind. Then we will go for the regular singular case.